And these are our next speakers. So 2 weeks' time, we have Christian Prifty, who I'm also really looking forward to hearing about. Christian will be talking to us about how to use a Power BI data set feeding into Power Automate. Then we have Greg Deckler. Brian has agreed to present for us, and he's going to be talking about DAX for humans. And then we have an in-person event with Alan Murray, who will be talking to us all about Power BI and Excel. And he'll also be showing us some of the really key, new, interesting things coming out within Excel. Wyn Hopkins then at the beginning of December is going to talk to us about ChatGPT. And so I've got a slot here which would be perfect for a new speaker if someone's interested towards just before Christmas, so that should be quite fun. And then we've got Chris Webb and Laura GB. That will be an in-person one, but I'm going to see if we can get the in-person ones recorded. And then in the middle of February, we've got Christian talking about error capturing. And so I've got another slot there for a new person if they would like to join. And so we've got 2 slots ready for new speakers. So guidelines, if you can make sure that your mic is muted and your video is turned off if possible. Any questions, please type them into the comments in the chat and put a Q in front of them, and I will watch out for them, and I know Brian normally stops at various points so we can discuss. If you've got any problems with the internet connection, please drop off and join again. And our meeting is recorded and I'm recording it now. So, if you have to leave at any point, I will be putting a recording up on the YouTube channel. So if you're ready, Brian, without any further ado, I thought I would pass over to you. And let's get cracking, because I think that's why we're all here, rather than listen to me. So if I stop sharing, and I'll let you share.
Thank you, Sue. I just want to check. I switched over my internet connection. I was getting some messages that the quality was deteriorating. So can everybody see and hear me all right?
Yes.
Okay, great. And let me just get this up on screen. Okay, so I'm thrilled to be here today, and Sue and I have worked together for a long time and been friends for a long time, and I'm always happy to see her and a lot of the familiar faces in the crowd today. But also, as some of you may have seen earlier this week, I posted about user groups in general, and I really think that user groups are, as I said, kind of the hidden treasure of the Power BI community. And I was kind of surprised at how many people were not aware of the user group resources that were out there in general. And so, I really, it's something that I really want to focus on and, make sure that folks know about, because I think the work that Sue, you're doing, and Christian, and the folks all around the world. I think there's 329 active Power BI user groups, and then I think there's another whole layer of Fabric user groups. Some are converting, some are additional, and so probably close to 400 groups worldwide. And I really think this is an amazing part of the community, and I'm just really thrilled to be here today. One thing that there always seems to be some sort of Murphy's Law corollary kicking in on these. And what happened on this one was I had done a corporate presentation of a lot of this material about a month ago, and so I thought, oh, I'm all set, I'm well prepared. I'm not doing my normal, stay up all night the night before. And then this weekend I opened the file and it was corrupted. So I've spent the last 2 days kind of trying to rebuild everything. I think I've got it set. It may not be quite as polished as it was, but I'm hoping I've got everything working well,
Yeah.
but
I can vouch for that because Brian pinged me at 9 a.m. this morning UK time, so I know what time it is his time, and I went, "What are you doing awake? Stop it!"
yes, I was furiously scrambling trying to get this back up to speed. So I just wanted to kind of briefly talk about, kind of why this topic, and when Sue approached me earlier this year about doing this, why I picked this one. And it's one that I've really thought a lot about. It's really influenced my own DAX and Power BI journey. And it really goes back probably 4 years ago to some work that I did with Melissa DeCorte, who, for those of you know her, she is just a world class um, and Power Query resource, and she was the one who kind of got me into this whole offset approach. And as I've been thinking about it and kind of how this plays into some of the bigger issues about DAX and kind of my whole philosophy about DAX. Um, one of the one of the things that was funny was when this session got announced, there was a message that came out, and here, let me just get this up on screen. This message got posted by Ladia Bardelli on LinkedIn, and it was it was a wanted poster about Greg's and my efforts to improve time intelligence. And the reason I post this is it had one of the funniest responses I've ever seen. Greg just casually said, when he saw the wanted dead or alive poster, he said, "I have two ex-wives. This isn't the first time I've been marked for death." And that just cracked me up. And so I I wanted to show that the information we're going to be sharing today is put a price on our heads. Um, so the thing that really got me thinking a lot about DAX in general and kind of the way we do DAX and the way we teach DAX is a meme that Carlos Barboza posted a couple of years ago. And the thing that really struck me on this was at the time, um, and it accrued a lot more responses after this. But at the time I saw it, this had 950 likes. And I've been posting on LinkedIn almost every day for 2 years. I think I only have two posts that have ever gotten that many likes. And so I thought, what is it about this that resonated so much with people? And the more I talk to people, and the more um, I kind of delve into the whole question of how do we do DAX? How do we teach DAX? I think for those of you who saw the presentation at the Persia Power BI user group meeting last week about visual calculations, I think Microsoft is really, thinking a lot about how do we simplify DAX. And this really struck a chord with me because it really shows, and it's something that in talking with people, I really see there is a lot of people struggling with DAX, and there's a lot of, I think, barrier to entry in Power BI because of DAX. I would say DAX, I think, is the biggest barrier to entry in terms of beginning users coming in and kind of quickly feeling out of their depth with DAX. And I think there are really four problems in learning DAX. And one of them is context is just a difficult concept. And I think people struggle with, filter and row context, evaluation context, context transition. And that's just something I think, everybody is going to have to, kind of dig in and work. And I think one of the things that I really like is there's a real diversity of presentations out there. I saw, Sue, that you've got Greg on DAX for Humans. I think DAX for Humans is a phenomenal resource, that without getting into the whole calculate, no calculate, discussion, I think it's just a really fascinating way of basically saying, let's step back and see if we can teach DAX from the start in a coherent, kind of cohesive way that maybe helps some of the people for whom the current methods of learning and teaching DAX are not working. And so, I think there's a lot of good work being done. I think Brian Grant, who I've seen present at the Portland group, he's got a different approach. And I think it also gets at kind of understanding context better. Bad data modeling is a huge one that when I was really active in the forums, one of the things I saw was that about 30 to 35% of quote DAX problems are really modeling problems. That people say, I don't know why my DAX isn't working. The answer is your DAX is fine, but your model's broken. And so, again, I think not only in that case is, it's think about how we teach modeling, but I think the entrance of ChatGPT and AI into this discussion, I think, is really going to change that to a large extent. And I've been posting and doing a lot of work in terms of kind of how do we prompt AI through the BIM files and through the data files to basically serve as an expert advisor on data modeling. And so I think there's strides being made there. The other two are really DAX related. And I think it's one is using DAX too much. That I think this kind of gets to Roche's maxim and kind of pushing things closer and closer to the source if you can. And for some reason, I think DAX kind of draws attention and attraction, and people immediately start trying to solve their problems in DAX. And the way I think of DAX is really as a last resort. That if you've got something that is not dynamic within the context of the reporting session, push it closer to the source. And so, kind of reserve DAX for only those things dynamic within the context of the reporting session. And then the last thing that I really will talk about today is not only using DAX too much, but using too much of DAX. And there are over 350 separate DAX functions, and yet you really can not only get by, but I think you can thrive with DAX with using only about 20% of those. And it's good to have awareness of the others, but one of the things that I've seen in terms of this offset approach is you can take 40 separate functions, each with their own complexities and idiosyncrasies, and in some cases flat out problems, and you can throw those overboard. I spend no mental energy on 40 time intelligence functions. I don't use any of them. I haven't used one of them in 2 years. And I think that in and of itself, the kind of paring down of DAX and making it simpler, for me has been a huge help. And I can only imagine somebody coming into this arena and trying to learn Power BI in kind of a quick but rigorous way. And I think that kind of paring down DAX in that way really makes a big difference. And I'll show you what this involves. So in terms of my beef with time intelligence functions, a lot of it is they're duplicative, they overlap, they're fragile, they break really easily. That if you deviate from a star schema, they break. If you deviate from the granularities that they cover, they break. I think they're very confusing. There are a lot of them that seem to do the same things, but when you get into it, some capture the endpoints, some don't. There's some real inflexibilities and inconsistencies. And as I say, when you get into and get comfortable with the offset approach, they're wholly unnecessary. And so this really is, and I credit, this entirely to Melissa in terms of kind of bringing me into this world. And the incredible thing about this is it's so simple in that if you think about, the time intelligence that you do that's the easiest, I would say almost everybody would say years. is the easiest because they're just numbers and they're consecutive, and you can move forward and back with years in a way you can't with other granularities. And so all offsets really does is it makes everything work the same way. So your offset is calculated, in this case, calculated through the dates table. But I'll show you also how we can calculate those on the fly in DAX if you don't have that date table available. But either way, it works the same way. Your present period is always 0. Your first past period is -1, second past period -2, and then future period is +1, +2. And the beauty in this is you're not limited to any set granularity. It works with years, quarters, months, semesters, trimesters. I had one where somebody had money that was allocated on a 2-year cycle, and so they wanted to basically have 2-year periods in their calculations. And basically anything you can define, you can say, okay, that I have a period that is 17 years and 1 quarter long, except in leap years where it's 2 quarters long. And as long as it's a predictable pattern that you can specify in a function, you can create an offset for it. And so this is really the flexibility and consistency in this is really where the power comes in. And as I mentioned, the engine that I use for this, and that I know Sue uses for this, and many of us who are kind of on this train, particularly from the enterprise DNA side of things, is Melissa's date table. And this is a marvel. I mean, this is the best date table out there, bar none. And one of the reasons is that she is really active in the community and is regularly updating this. So when there hasn't been an update in a while because it covers everything. That it's got not only a full set of offsets, but it's got the capability for a holiday table you can insert. It's got functions like is after today that separate actual data from forecast data really easily. It's got business days, weekend days, holiday days. So any combinations of when businesses might be closed, you can start the week on different days. It does everything. And this is a resource that's free, whether you're an Enterprise DNA subscriber or not. It's right in the forum. I can provide Sue the link for this after.
Donald's already put it in the chat for you, Brian. We're there.
Wonderful.
We're there.
Wonderful. And so this is really the place where I'm going to start in terms of the offsets I'm going to show you, and some of the problems and the solutions I'll show are almost all based on this, but they're very easy to replicate. And the nice thing about this is you can really go through and follow Melissa's logic in terms of exactly how she creates each of these offsets. And the code is beautifully documented. It's commented, it's clear, and she is extremely responsive. So if there are any questions, she can certainly take those, and is very open with the community to making additions and adding things in. So at this point, I want to see if there are any questions, and I want to jump into some really in-depth examples and talk about kind of some of the issues and problems and solutions.
No questions as yet, Brian. Lots of discussion in the chat, and Melissa is coming to speak to us in the new year, and I'll pop her LinkedIn profile in the chat now so that people can connect to her, because she does produce some amazing posts, really worth following. So yeah, we're all chatting amongst ourselves, so you carry on.
Yeah, unfortunately I can't see the chat, so if there are any,
Don't worry.
I really love for these to be kind of open discussions,
Yeah.
and so don't feel hesitant at all to interrupt if.
I'll interrupt. Don't you
Okay.
worry about that, Brian.
Thanks. So this is the first thing I wanted to show, and this is year to date. And the problem I've identified here is just black box. That if you look at the year to date function, and let me find this. Okay, here we go. I've got everything kind of popped in folders. So if you look up here, and let me try to increase the size of this a little bit. These are really simple looking functions, and just a few lines, and you think, okay, this is beginner stuff, and it is, except for the fact that they don't work the way you think they're going to work all the time. And people say, oh, you can just pop in total year to date, and it'll give you the your measure year to date. And I'm like, are you sure? Because there are some cases where it will and some where it won't. And the examples I'm going to show are based on real world cases of questions that have come up in the forum, or questions that I've encountered in my own work. And the first one I'm going to show you is it's a Kaggle data set. These aren't engineered in any way to kind of make the functions break. They just break on their own. And this one is basically just it's sorry, I've got the Teams thing in the way. Okay. And what this is okay, daylight minutes, a really simple data set where it's just it happens to be for Toronto for this year, and it's the sun up, sundown time, and the number of daylight minutes. And so what we want to do is just figure out year to date how many daylight minutes we have at any given point in time. And the one thing,
right, Brian, just sort of a quick question. When you get a chance, can we see the data model again?
yes,
whenever you're ready.
Really simple data model. So I've got two examples in this file. Basically, I've just got Melissa's date table hooked to the daylight minutes, and it's connected by the date field, which is marked as a date table. And then I've got this other one that I'll show you for quarter to date, that is a different case, but kind of some similar problems. And actually, before I do that, let me jump into real quick. Let me jump into there's another example that I think will kind of show the general approach in a really good way, and will help kind of provide some background on that. So this is the fragility and flexibility, and what I mean by that is the can time intelligence functions generally do okay when you're at year, quarter, day, and year, quarter, day, and month. They tend to work fine. When you deviate from that, though, they basically just give you the big shrug. And so, in this case, fiscal years, any sort of fiscal period, they cannot handle. They're just going to break immediately on you. And the other thing they can't handle is weeks. And that's one that gives people a tremendous amount of problems, is handling the ISO weeks. And what I want to do is just show you in both cases kind of the simplicity and the kind of repetitive nature of the offset approach. And so in this case, let's take a look at the measure for fiscal years. And again, this data model is really simply, this is the practice data set that I've posted a number of times that Melissa, Steve McGuire, and I developed that basically just creates a 4-year star schema, standard, sales, customers, products, regions, and it's a really helpful data set for this sort of testing. And so I've got the link for it. That it's free. It pops right in your external tools menu. And so let's take a look. First at the fiscal year measure. And okay, so our pop measures here. So this doesn't look simple, but it is. And basically, all this is doing is basically taking and it's putting into a variable the selected value of our current offset. So it's taking the current row and it's grabbing the offset for that row. And then it's taking the previous period as just the selected offset -1. So going back to that PowerPoint slide, whenever we're kind of sliding back and forth, you can kind of think of it almost like a slide rule measuring time. We're sliding one period back to get to the previous fiscal year. And the way I like to do these, I tend to write these quite verbose, and you could definitely write more compact DAX. But the thing I like about this is it basically says, okay, we're going to take a table and we're going to take all our dates and we're going to filter by the selected offset. So this is the current period table of dates for that fiscal year offset. And then we're going to do the same for the previous period. And then all we're going to do is we're just going to sum total sales over the current, total sales over the previous table, and then we're just going to calculate a percentage. And that's all this is doing. And the nice thing about this is, I think, at any given point, you can either through 2CSV or in tabular editors, Sue's been presenting on a lot lately, you can pop this in the tabular editor and you can see exactly what your DAX is doing. At every table step, you can do that. And the nice thing about this, as opposed to, say going back to the year-to-date measure, which is just the TI function year-to-date measure, which is just a 3-line scalar. There's no way really to pull that apart and look and see what's that doing internally. So when we take this basically then gives us our period over period. And then the great thing about this is it's completely repetitive. So if we take weeks now and we look at the week DAX, it's the exact same structure. All we've done is we're just pulling a different offset. Instead of pulling the fiscal year offset, we're pulling the current week offset. And then we're moving one back on the slide rule. We're calculating current table, previous table, sum X over the current table, sum X over the previous table, and percent. It's the exact same thing. And the thing you'll find with the offset approach is basically that kind of formula of figuring out where you are currently on the offset scale, and then specifying where you want to be, and then just filtering based on those boundaries. That's really all there is.
Yeah. Would you mind just explaining how with the variable you keep the actual value within, and then how you use all so that you can slice back and forth? Because I remember when I first started learning, I didn't realize that the variable was actually a constant.
Right. And that
does that make sense? Yeah.
Absolutely, absolutely. And so what we can do is we can actually go down and look here at the fiscal year. And so what it's doing is, filter being an iterator and then having that variable in the top of the measure. Basically what it does is it looks at this fiscal year, and then through the date table, it says, okay, what's the offset associated with with that fiscal year, and then it returns that number as a constant in the calculation, and then says, okay, another constant is that offset -1, which is kind of in this case off the table. So there is no value for that. And so when we try to calculate this, there's nothing returned. But then we go down to FY 2022, and it pulls the offset for that. And so given the fact that we're in in this case now, for this table, we are in FY 24, because the cutoff just in the way I built this table was that it was everything from July 1st on was the next fiscal year. And that's completely configurable in Melissa's date table. It actually asks you in the setup what your fiscal year cutoff is. And so
Brilliant. Thank you. Thank you.
so this is basically FY24 will be our zero offset. And so what it's doing, it's basically just saying, okay, for each of these years, what's the offset? It's holding that in a variable constant, and then calculating the previous, and then calculating the percent change between the two. Then when it hits the return statement, if we go fiscal year pop, when it hits the return statement, then it goes up and puts the next line in the variable and goes through that same process. And so you're constantly just current offset and then stepping back. And so when we get to weeks, it's doing the exact same thing. And when we calculate that out, that now shows up here, and we can do any sort of manipulation on this that we want. And so that's kind of the general formulation. And so if we go back to the one we started on, and the one thing I'll tell you about this, this is kind of funky. You know that saying that even a broken clock is right twice a day? The same thing is true with DAX time intelligence functions. Even when they break, they're right occasionally. And it just so happens that the examples I had put together are correct for the fourth quarter, but the fourth quarter only. But given that it's the fourth quarter now, that what I've done is I've actually set quote today in Melissa's date table to be August 15th rather than October 17th. So keep that in mind when you see these results, that this is as if we were running this on a current day of August 15th. So if we go back to the data model on this one, this is just the daylight minutes, and it's just the date, and then it's the sunrise, sunset, and then in M, because that's not dynamic within the context of a reporting session, I did that, pushed that calculation up rather than doing a date diff or something like that. And so we've got in the data set the actual daylight minutes. And so all we want to do in this case is we want to calculate how many daylight minutes have we had so far this year to date. And the interesting thing is, if there are two ways to calculate year to date using canned time intelligence functions. There may be more than that, but two that I know, one of which is total year to date, Um, and let me, daylight minutes. Okay, so there's dates total year to date, and there's total year to date. And they should return the same thing. And in this case, they do. They both return 268,000.2 minutes for the year. And you look at that and you go, okay, it checks out, except it doesn't, because in that construct, basically the function is reading, it reads all the way to the end. That it does not stop at the current date. And this is whether we set, the current date to August 15th or October 17th, it will continue to tally as long as there's data in that data set. And the assumption is you think year to date, that means year to today's date. And that's a reasonable assumption. That's not what it does. And the thing about it is you can't tell from looking at it whether it does that or not. And again, the beauty of the offset approach is if we look at the offset approach, total year-to-date offsets. Okay, it looks a little more complicated, but again, it's quite straightforward when you break it down. That we're just pulling the current date in context. And then what we're saying is we're pulling, in this case, we could have just put all dates, but I know, some people, even for dimension tables, don't like to filter on a whole table. So we just pulled the fields that were necessary here, the dates and the is after today, which is, as I mentioned, a function that Melissa calculates as part of the extended date table, which breaks actual to future. And so all we're doing here is we're taking all those values and then we're filtering by less than or equal to the current date in context, and is after today is false. So we're explicitly cutting off and saying, okay, after the present day, this calculation stops. And that is the essence of a year to date calculation. And the thing I like about this is you can look and see exactly what this is doing. And you can also take, as I said, and we can go and put this into, in the tabular editor and see exactly what dates are included, what dates aren't. You can put it into an active pivot grid. You can put it into a DAX query, and it will show you exactly what it's calculating based on. And then we just calculate the total daylight minutes over the sum x for that filtered table. And what we get is actually an accurate year to date, which goes up to the present date, which is, in this case, August 15th, and then stops. And so, that I think is a real red flag in terms of, kind of using black box functions that you think work in a certain way, and then when you test them, they don't. And the interesting thing is, I got in a big discussion about this with some of the folks online when I posted this, and it was interesting because even the people who are kind of very, I think what I would say are traditional DAX, adherents, they said the one function they steer clear of all the time is quarter to date. Because if you think year to date is broken, wait till you see this one. And this is a this is one that is just maddening to sort out and figure out what this one is actually doing. And so in this case, what I've got is this is based on a problem that came to me in a forum question, and it was somebody who was managing a bed and breakfast, and I've simplified the rules here, but basically what this is again, very simple data model. It's a date table and a fact table, and we can look at the bookings table, and there's the rule in bookings is that you can book any time in advance in the calendar year, but the sales do not get realized until the actual date of stay. So, what we've got here, and if we, if we see here that, thinking back again, that our present date is, today's date is August 15th. What you can see is we've got rooms that are booked all the way out through December 31st. But we don't have any realized costs past August 15th. And so if we go back to quarter to date, this is where kind of the inaccuracy and ambiguity just becomes absolutely crystal clear and kind of maddening, in the sense that if we kind of break this down for 2023, and we think about, okay, what would we expect a quarter to date and a quarter to date bookings and a quarter to date sales measure to return? It's actually an interesting question, that the quarter to date sales should just return this 85.8, and that's the total sales that have been realized in this quarter up to the present day. That seems pretty unambiguous to me. The total bookings is interesting. I think you can really make the argument that there's two different numbers that could be correct in the interpretation of this. One of which is, you could say, okay, given the fact that you can book in advance, that the third quarter to date should capture either the quarter up to today's date or the entire quarter, given the fact that you can book in advance. So at today's date, there are bookings that occur out further in the quarter. And I think you can reasonably make a case that either of those could be a correct measure. And I think you really, this gets to the data dictionary and defining your calculations. Well, the interesting thing is that the canned quarter to date function returns neither of those. The canned quarter to date function returns 747, which is the total bookings out to the end of the year, which I guess you could make an argument that those are also booked in the quarter to date, but that is a strange interpretation, I would say. At charitably, that I think is the least likely interpretation that one could make on this. And the other thing that is pretty clear that this is just not working correctly is the total sales that it returns quarter to date. It just returns a blank. And what it's doing is it's chugging through the entire data set and not stopping at the quarter to date. It's continuing on into the fourth quarter, even though we've got that quarter to date, which should stop. And that, to me, it's like you can't predict what this is going to do in a given data model and a given data set construct. And as I say, even the people who are, pretty comfortable and pretty much advocating for the can time intelligence function, they'll tell you this one is just a stay away. And if we look at this in terms of the offset approach, again, it's really, really clear, that we can go into our offset measures, and let's okay, here we go, offset quarter to date. And so, we've got our quarter to date sales. And given the fact that I've got a lot more to cover and I don't want to take too much time, let's just jump right into the bookings. So the book for the entire quarter, again, same thing over and over again. The booking for the entire quarter is we're filtering the entire table, the entire dates table, the fields we need, and we're saying the current quarter is offset equal to 0. Definition of an offset, current is always equal to 0. And then we're taking that filter table, running it through the SumX of total bookings, and we get the entire quarter, because in this case we're not breaking the granularity down beyond the quarter offset. We're just saying the entire quarter offset gets the sum. Now, if we go to this one, what we've done is we've basically taken the exact same approach, but then introduced a second condition into the filter, which is after today is equal to false. So now we're splitting the quarter into before today and after today. And that gives us kind of the additional precision to come to this 390. And so the great thing about this, is that it follows the same pattern each time, but it really gives you, I think, incredible kind of fine-tuned control of exactly how you manage your movement along that scale. And the other thing is that, I didn't comment this out, but I would under a normal report case. And so anybody looking at this who's got any concept of the approach can look at this and say, okay, I understand exactly what this is doing. I might not agree with the interpretation of which measure should be used, but I understand how both of them were calculated. And again, that until you play around with the can time intelligence and really test them, you just look at.
I've got a question for you. Yeah, I've got a question for you, Brian. But yes, it's and also if you in Tablet Editor, what you can do is you can push the measure definition, so that when you hover over any of the measures, you can see specifically how they're calculated. So any user that is using your data model will be able to hover clearly and see what the expression is. And it makes it very, very clear, after today is false. So it's only occurring. So David Copeland, hi David, he said, why use SumX over the filter table rather than just to calculate sum with the offset filter?
That's just because that's my own personal no calculate philosophy coming in.
Yeah, you're sprinkling oil on the fire, David.
And I didn't want to get into that, just because I don't want to confound the two. And so for people who are not on board with the no calculate approach, this works absolutely perfectly fine by doing exactly what David was asking. And you could rewrite those absolutely as, calculate the measure over the filter table, or filter the table within the calculate statement. I certainly prefer doing it without the calculate, just because I think what it does is it gives you that additional insight into, table iterator, and being able to, again, go into Tabular Editor, DAX Studio, or 2CSV, and really see if at any point your measure is producing an unexpected result. I think it's just a lot easier to break it down that way. But you absolutely could. I don't want to imply that this offset approach is tied in any way to the no calculate. I think it complements the no calculate beautifully, but it works just as well with with calculating. I think Melissa, for example, when she teaches this or in her own work, she uses just a standard calculate function. So any other questions on that?
No questions really. I think people are just, we've had a couple of nice comments from people that are fairly new to DAX and just saying they're learning a huge amount, and there's lots of lively debate in the window. Oh, Craig's asking a question. He said, sorry, Craig, I'll just read it out. Apologies for the late question. If I'm understood correctly, in your first PBIX, your FY24 is still active. How easy is it to make a year-to-date comparison between FY24 and FY23 like for like? In other words, fiscal year 23 cuts of year-to-date on the same day as fiscal year 24. So you've got previous year-to-date compared to year-to-date with the filter is true. The filter, so, you know, when he's saying date is after today, how easy is that for the previous year to date to have date is after today as well?
Very easy, very easy.
I think if I explained that correctly, Craig, just put a thumbs up or something if I've asked. But I know exactly what you mean because I was working on this the other day. So I'll hand over to Brian.
And I've actually got 2 YouTube videos that go into depth on this in terms of doing exactly what you'd asked in terms of kind of comparing like for like, and then even a way using some of the additional functions to compare like for like, not just with dates, but with composition of the week. So making sure in a given period, you're picking up the same number of weekend days, the same number of holiday days. And there's a very detailed video I have that I can find after this and pass the link on to Sue that walks through exactly how to use this offset approach of comparing like for like on a day basis and on a week composition basis. And so, yeah, it works beautifully for that. So the next thing I'll show is just that we've talked about the difficulty, in debugging the time intelligence functions, but there's also, I think, complexity in what I call mental load, which is we look at these. I've got the list of, I think it's 42 time intelligence functions that are defined in the SQL BI DAX guide, DAX.guide online, and each of them functions differently. To me, this is a heavy weight to carry. I mean, you're traveling with a big bag of functions there, and they all, as I say, they all operate differently. And I think if we look at kind of a very common construct, which is creating kind of a variable parameterized moving average, where we can basically move this slider and adjust the moving average for any number of months. And if we look at the oh, and one thing I'll show you here is if we were to take the TI function out, the offset function just sits right beneath it. So they're returning the exact same results. So if I put the DAX function back, yeah, you can see they coincide exactly. And so what I want to show in this was I wanted to show again the comparison. This is the SQL BI kind of standard pattern for parameterized moving average. And I'm not going to say it's the most complicated function you'll ever see, but there's a lot going on here. When I looked at this, I had to look at this and see, okay, kind of work through exactly what this is doing. I had to go back and look up dates and period because it's not something I use. Doesn't include the endpoints, does it not? What are some of the other characteristics of that? And now if we look at the offset, again, this is going to get boring, but it's the same thing over and over again. It's just you find the current offset, and then you just you strip the filter off, and then you just apply the filter based on the offset bounds that you wanna calculate. And so in this case, it's you want to be less than or equal to the current offset, and then greater than or equal to the current offset minus the slider value of the number of months you want to calculate the moving average over, and then just adding 1 to account for the endpoint. And so, all we're doing here is basically saying, okay, if this is the current, then we want to slide back, 5 clicks on the offset, and then calculate the average over that period. Then we go to the next period and we do the exact same thing. And so, just like the year to date, the quarter to date, the the initial one we showed, it's working the exact same way with no additional functions. It's all just filter, all, and variables. And so, that is kind of where I think both the mental load and the debugging really plays in. The thing I wanted to show is I wanted to go back to our kind of the infamous quarter to date tables, and I wanted to show because I think people always ask, okay, this offset approach sounds so great. What's the downside? And quite honestly, what I've always said is it's really dependent on your ability to use a date table with the offsets built in. And so, people say, well, what if I'm in a situation, which a lot of people are apparently, where your organization dictates the date table you're going to be using, and there are policies such that you can't even add calculated columns to that date table. That table has to remain, pristine in the form that it comes in from the data warehouse. And so in the past, I've always thought, okay, that's kind of where, where we part ways. And Greg Deckler has said, no, you don't have to stray from the path. That what he has done is, in the perhaps overly confrontationally named "Your DAX is Garbage" video, he has posted a whole range of. Let me show you this. A whole range of calculations, and this is all available on his GitHub, where he goes through year to date, quarter to date, month to date, week to date, and shows in every case how you can create an on-the-fly index just using variables and measures. And if we look at, if we go back to my file in that quarter to date, what I've got is a variable offsets quarter to date bookings and a variable quarter date bookings for the entire quarter. So regardless of which definition of quarter to date you use, you can calculate this without Melissa's date table at all. And I'll show you, it gets a little more complicated, but it again doesn't stray too far from the general concept. And so really all Greg is doing here is, in this case, I've got today, quote, today set to August 15th. And then what he's doing is he's taking the date table, and instead of adding a calculated column or modifying it, in Power Query or in SQL, he's basically modifying it right in the DAX measure. And he's taking and saying, okay, the year times 100 plus the quarter is going to give you an integer value that you can slide. It's not exactly um, conforming to our definition of offset in terms of the period being 0, but it still allows you, instead of using kind of the subtractions, is to use the max and then less than or equal to or greater than or equal to. And what this is doing is it's basically just saying, okay, we're creating the offset on the fly by creating this integer value that captures year and quarter. And then we are calculating the today value, which instead of it just being a simple selected value from the dates table, is calculating as the max of that virtual date table with the integer index built in, and then saying we want the max of that subject to the cutoff that it can't be that the date is equal to today. And so what that's going to return is that's going to return the index value that would be equal to typically what it would be our 0 offset value. And then all he's doing here is summing the bookings over quarter to date by saying that the quarter to date has to be the quarter offset basically has to be equal to that quarter offset that we've determined here, and the dates has to be less than or equal to today, which is the equivalent of the is after today statement that we've been using from the date table. So the DAX is a little bit different here, but the concept is exactly the same.
So we've got I got a question. Just how does Greg's version impact upon performance? Because obviously we've got iterators within iterators, but I'm suspecting probably not too horrendous because it's a date table, so it's not massive.
It's not massive, and this is really interesting, and I will tell you, I didn't believe it when I saw it, and Greg's got he's got all the data up on GitHub. You can run it yourself. That in all of these cases, even the on the fly offset calculations calculate much faster than the can time intelligence. It's not a matter of you're willing to accept a little performance hit. You actually gain performance relative to the can function. And in many cases, if you're using the date table directly, it's by a factor of 10.
Gosh. I didn't expect that at all. I didn't expect it to be too horrendous because of the size of the date table, but faster. Whoa.
But it actually runs much faster. And the interesting thing is, in some of the debates I've gotten into with folks about the no calculate approach, they say, well, the reason you're maintaining parity over a large number of measures is because of the fact that the can time intelligence functions are so slow. That's where you're kind of picking up. I don't necessarily agree with that based on the experimentation and statistical analysis I've done. But the interesting thing is, even among the more traditional, DAX, kind of calculate crowd, they will absolutely admit that the time intelligence functions run really slow in some cases, and particularly in these 2 date cases. I'd really, if you're interested, I'd really encourage you to watch Greg's video and download that and play with it yourself, because the numbers are spectacular.
I've been diving into his DAX for humans, and it's a really, really nice, simple approach. But yeah, that's fascinating.
And so, that's really, because when I first saw it, I thought, okay, it frees you up from the constraint of needing Melissa's date table, but it probably takes a pretty big performance hit as a penalty. It does not. And so really in this case, what I would say, in terms of the quote downside is a little bit more complexity if you have to create the offsets on the fly. But the other thing that I haven't tried yet, but that I want to try, given the performance issues, I think what you could do is I think you could run a simple rank function on, and the rank functions tend to perform quite well. And so run a simple rank function and then convert this kind of non-conforming offset integer into one that meets the 0 for present, 1 for the next future period, -1. And I think if you did that, I think it unquestionably would take a performance hit relative to the way Greg has done it. But I still think it's quite possible that it would perform equal or better to the can time intelligence. And in that case, then you've really got the consistency of approach with the definition of offset. So that is really, I think, where I'll stop now. I know we're a little past the 2 o'clock hour, but I hope that's been helpful. I hope it provides at least some food for thought and maybe some impetus for experimentation. If you haven't tried this, I find it's been a wonder, that once you get used to the pattern, it's just the same thing over and over, and it makes your DAX so simple, that even the most complex time intelligence gets handled in a really modular way, that you can kind of attack it, kind of piece by piece, look at it, what it's doing behind the scenes, and really figure it out in a way that is just very difficult to do using the other functions. And then you gain the speed, you gain the flexibility, and you gain the transparency. So, to me, it's just it's a win-win all the way around. So I'll leave it at that, and be happy to answer any other questions.